Hello everyone, my name is Mohit Pal Bikram. Today I'm going to talk about the phase transition and critical phenomenon. The outline of my presentation is phase transition, condition of phase equilibrium, first order phase transition, second order phase transition, critical indicates and laws corresponding states. So first I want to talk about the phase transition. So this is the has the different occurs in different matter, solid, liquid, gas. Solid shows the Bragg's reflection because of order arrangement of atoms and molecule. Liquid and gas no longer is the arrangement of molecules. So phase transition of a matter from one phase to another which coexist with the first. Change in the mutual arrangement of molecules and change in the thermodynamic property of the system. So phase transition points. So these depend on the pressure and volume. So phase diagram of the one component system shows here. So you see the solid gas and gas curve. The saturation curve, the termination point and C, critical points, and O is the triplet points. So here I want to show you the phase transition graph in one state to another states, solid to liquid to gas. Solid liquid gas transition known as the melting and freezing. Solid and gas transition is sublimation and deposition, liquid and gas transition is known as the vaporization and condensation. So point of at the triplet point, you will see the all three states. Melting two will see the melting curve and normalization boiling point, critical points, and at the different temperature and pressure, you will see the different points. So type of the phase transition, first order phase transition, second order phase transition, discontinuous change in the integration energy and volume, heat involvement, absorption in the first order phase transition. We see in the solid to liquid, liquid to gas. The second order phase transition is smooth change in the energy, in the volume, no heat involved and absorption in. So this second order phase transition you will see in iron, the ferromagnetic materials, the paramagnetic state as the critical points, and liquid helium is the first to liquid helium at the second. You can also see the equilibrium curve divided by the phase point 1 and 2. So if G1 point is less than G2, you will see the gives free energy, you will see phase 1. G1 greater than 2, you see the phase 2. And n is the equal, you will see the curve, the equilibrium curve. Which define the curve, the pressure and temperature. At the point of the curve of Gibbs free energies of two phase are same. Two phase can't be the equilibrium with each other at the odd pressure and temperature. So first order phase transition is well known as the Celsius and Capson equation. Consider of two phase, one or two. Gives free energy of the equilibrium. You see the equation 1 and 2. And phase equilibrium curve at point P and the function of T. The melting curve, solid liquid transition, phase curve, gas transition. Equilibrium of three phases is governed by the different points. When you solve all these equations, we see the pressure as TR, T as the PR. So it's called the triplet points. And second order phase transition is a continuous in the sense that the state of system change, the continuously a symmetric change is discontinuous at the transition point. In case of the transition between the different crystal modification, there is a sudden rearrangement of the crystal and the state of the system change discontinuously. If you see the cubic lattice PiO3 molecule. So the modification in the another is called the second order phase transition. The law of corresponding state. We know that the van der Waals equations can define the law of corresponding states. Essentially applied the critical to stay in the real over the wide range of densities and temperature. The van der Waals curve maximum and minima in the range of represent the horizon line. Extend the curve, the system maximum and minima points. Some close to the rise of the temperature, the causes of the critical temperature, which kick to the isothermal maximum and minima disappear. Point of the inflation is called the critical point. In the figure, you can see the different curve at different temperature. If the temperature is greater than the critical, you see the flat curve. When your temperature is lower than the critical, you see the valley. When you locus the valley, you see the curve, and you see the critical point and critical pressure and critical volume. So thank you. So this is my presentation on the phase transition and critical family. Thank you.